Hi folks, welcome to lecture 6, and we'll be taking a look at ratios in this lecture. So a ratio shows the relative size of two or more values. So say if we're in a pet shop, there's 6 dogs, 4 cats. The ratio of dogs to cats can be written in several ways. Be very conscious though guys, the order. So if we're saying dogs to cats, we always write the dogs first. If we're asked to express a ratio of cats to dogs, it'll be 4:6. So it's very important that you write the ratio in the order in which you're expressing things. So a ratio can be expressed using numbers or fractions, where we look at the whole. There's 10 pets in the shop, 6 of those are dogs, so 6/10 are dogs, 4/10 are cats. We can convert these to decimals just simply by division. And then if we need, we could also convert to percentages by multiplying both sides by 100. So it's very important to realize, guys, that ratios, fractions, decimals, percentages, there's very strong linkages between them, and you need to be able to maneuver in and out of each of them kind of at will. So now, ratios are everywhere. Every recipe you come across, every chemical formulation, any compound, they're simply statements of ratios that certain ingredients or elements have in relation to each other. So we can multiply or divide each part of a ratio by any non-zero digit. So it's very important, guys, we can multiply or divide both sides of a ratio, and the ratio is preserved. What we really mean here is equivalence. The equalness of the ratio is preserved. So think of, you have a recipe to make a cake for 4 people, but you have 8 people coming around. You simply double all the ingredients. The ratio of ingredients to each other stays the same. In other words, the cake will taste the same, but we're simply making double the amount. With ratios then, it's always good practice to reduce a ratio to the simplest whole numbers possible. So with our example, both of these numbers, 6 and 4, are divisible by 2. So the correct ratio would be there's 3 dogs for every 2 cats in this particular pet shop. So we just take a quick look, guys. Just pause the video, have a quick go at these 3 questions. This should only take a moment or two. What's the ratio of blue to yellow? What's the ratio of red to blue? Remember, order is predominant. And then what fraction of buttons are red? So fairly straightforward, guys. I won't spend too long. I'll let you guys have a go at them. And now ratios that are going to appear in lots of different formats: decimals, fractions, percentages. We saw this in the earlier slide. Sometimes you might have minutes is to hours, grams to milliliters. We'll see these before the end of the lecture. So always bring these to simplified whole numbers. So say if we're given a decimal like this, it can look quite confusing, but really, guys, it's actually very simple. It's like when we were dividing by a decimal. We want to turn both of these to a whole number. So on the right hand side, we need to move the decimal point 2 places, so we do the same to the left. So really what we're doing is multiplying both sides by 100. We now get 10 is to 12. So written, 2 will go into both of those. So the correct way to write this ratio is 5:6. So always try and use whole numbers in their simplest form possible. Sometimes you get fractions, guys, and again, these tend to wreck people's heads a lot, but again, it's the same principle, guys. We want to turn these into whole number equivalents. So first thing we want to do is get a common denominator, which we can see is 4, is a quarter. Now the right hand side is written as quarters, so that's okay. The left hand side, we just simply multiply above and below by 2, and we're going to get 2 quarters is to 3 quarters. Now what you can do here, guys, is simply ignore, because we're comparing quarters to quarters. These are the same, so we just actually take the numerators as our ratio and we ignore the quarters. So we've 2 quarters is to 3 quarters, the ratio is 2 is to 3. Similar with percentages, again this 25 will go into both, so the ratio of this is just simply 1 is to 6. So express the following ratios in their simplest form with whole numbers. If you can hear a strange noise in the background, Bella is chewing her paw and I can't reach her to make her stop, and she won't stop, so we just have to suffer through it. I hope you can't hear it, but it's very, there's this clicking noise in the background. So again, guys, these problems are for you to try. So express the following ratios in their simplest form. Now, again, like we saw, get the common denominator, multiply both sides by whatever you need to clear the decimals out of both sides. With the minutes and hours, guys, bring everything to minutes or to hours. I would suggest bringing everything to minutes to make your life easier, but either way will work as long as you're comparing like to like. You're good. And now, guys, we'll take a look at ratio pairs. These are very important. These are where we're going to encounter ratios most in this semester. And frequently ratios will appear in pairs. So these problems appear in lots of different guises. The method is the same. One example would be, say, if someone scored their CA test was worth 20 and they got 8, what would that be out of 100? This kind of an idea. If they were to be marked out of 100, so this was their score. So there's lots of different ways. I'll show you as we go along rather than making up examples. So usually, guys, we're given a reference ratio in the problem, and then we're asked to complete another ratio so that it is equivalent, equal to the reference. So best explained by example. So say a cake needs 2 eggs for every 400 grams of flour added. Well, if we had 3 eggs, how much flour would I need to add in order to make the ratio complete? So here, guys, this is my reference. 2 eggs is the 400 grams. So if I have 3 eggs, how much do I need? Well, hopefully it's obvious that it should be 600. But as we move on, we need something a bit more robust than just intuition. So we take a look, guys, and I'll talk through. Now, there's several ways of doing these, guys. Cross multiplication, blah, blah, blah. But I use this technique. It's called ratio scaling or scaling. So I use this throughout the course, guys. So it's up to you, but this is the simplest way, I would reckon. If you want to stick with the ways you learned in school, that's absolutely fine. But as the course develops, then you might find your slightly longer ways might cause a bit of error. But that's your choice, really. So in each problem, guys, regardless of how it's framed, you're going to be given the reference ratio. In other words, you're going to have one ratio where you know everything about it. So the way to set these problems up, guys, is to write the reference ratio on top. Now we write the other ratio with the unknown below it. And on one side now, we know all the information, and then we have our unknown on the other side. So what we want to do on this side, on the left-hand side, in this case, guys, is say, well, how do I get from 10 down to 2? Now, in this case, guys, it's fairly easy. If we divide both sides by 5, that brings 10 down to 2. So as long as I've established a path that works, I just simply apply it to the other side, divide both sides by 5, and our ratio becomes 2:6. Sorry, 2:6, like that. So that's our new ratio, and this ratio is equivalent to that ratio there. We look at another example. Now, this time my unknown is on the left-hand side, but I still have my reference ratio where I know everything. So this goes on top. Now, I write, always give yourself a few lines, guys, because sometimes it isn't too obvious. Now, in this case, it's fairly straightforward. We have x is to 36, but sometimes it's going to take several jumps. So that's why I always leave a bit of space, so I give myself a bit of room to work in. Now, again, guys, I have my unknown side and my known side. I know everything about the right-hand side. My unknown is on the left-hand side. So I use the right-hand side, guys, to develop a path. How do I get from 9 to 36? In this case, it's fairly easy. Again, multiply by 4. So I just simply do the same. So you choose the path down the known side, and then you apply that path to the other side. And as long as we're doing the same thing to both sides, we're preserving equivalence. So 4 by 4 is 16. And again, guys, this ratio is equivalent to my reference ratio. We look at another example. This is moving more into the territory that we want to get into. So we have 40 to 1,000 is equal to x is to 150. Again, my reference ratio goes on top, the one I know everything about. My unknown is on the left, and I want to get to 150. Now, guys, looking at the right-hand side, this is where I need to choose my path. There's no real easy way to get from 1,000 to 150 in one go, not without a calculator anyway. So what we're going to do is create a series of stepping stones. So what I'm really looking for, guys, here is what number will divide into 1,000 and into 150. So it's like the highest common factor again that we learned last week. What's the highest common factor of 1,000 and 150? And I hope you'll agree it's 50. So we write that directly above my answer. That's where I want to get to first. So it's easy now, guys. I'm going to do it step by step. First thing I'm going to do is divide, go to 100, because that's quite easy. Divide by 10. Now I can divide by 2. That's brought me to my stepping stone. And now it's quite easy to get from 50 to 150. So this technique, guys, it just takes a little bit of practice, but once you get used to it, it's actually very quick and very solid. So I've established a path down the right-hand side, and it works. Divide by 1,000 by 10, I get 100. Divide by 2 by 50. Multiply by 3, I get 150. So now I just apply that path to the other side. Divide the left-hand side by 10. You don't need to write it on the left, but I'm just showing. Now divide both sides by 2. Well, divide the left-hand side by 2. And now multiply both sides by 3. And there's my answer like that. So short overview, guys, again, write your reference ratio on top. Then, depending on which side your unknown is on, establish a path down the known side. that you're happy with. How do I get from 1,000 to 150? Once you've established that path, guys, then you just take the same steps on the left-hand side and your answer will drop out. So now in the next slides, guys, we're just going to take a look at how the same technique applies in different scenarios and more scientific scenarios than what we've just been looking at. Just before we go though, guys, when two ratios are equal, we say they are proportional. So when we worked out this was 6, we can say this ratio and this ratio here are proportional. And next semester, semester 2, we're going to take a look at proportionality in a lot more detail and why it's very important as a scientist. But first, we'll just take a look at a few ratio problems. Solution has 120 grams of sugar dissolved completely in 1,000 mils of water. How much sugar is there in 75 mils of solution? So, even though it doesn't look like it, guys, this is the exact same problem. There's our reference. We know there's 120 grams in 1,000 mils. Now, you have a couple of choices, guys. You could write grams on the top like this. I tend to just keep them as I go, though, because at least I know exactly what I'm dealing with. So this is my ratio. This is my reference ratio. Now I'm told, well, I have 75 mils of this solution. The question is, how many grams of sugar is there in 75 mils? So you can see the setup is exactly the same. Now, on my right-hand side, that's where I know all the information. I'm looking for the highest common factor. I'm thinking 5. But if you think a little bit longer, guys, you'll see 25 will go into both numbers. This is my stepping stone. So I want to use the right-hand side to get down to 25 first. What I'm going to do is divide by 10. That'll bring me to 100. Then divide by 4. And then multiply by 3. So the idea of these calculations I'm making, guys, always make them as simple as possible. You could divide both sides by 40. That'll get you to 25 very quick, but I always like taking lots of small, quick steps than big strides. So imagine you're walking on a tightrope. How would you want to go about it? Lots of little short steps is a lot safer than taking big bounding leaps. So that's the philosophy I apply. So guys, I've established a path on the right hand side that gets me from 1,000 to 75 mils. So now I simply apply the path, divide both sides by 10, I get 12. Then divide by 4, I get 3 grams in 25. And then multiply both sides by 3, so divide by 10. Then divide by 4, and then multiply by 3. So 3 by 3 will tell me there's 9 grams of sugar in 75 mils of this solution. What's very important to realize, guys, with this technique is I'm preserving equivalence at each step. So if I was to kind of put a scoop into this liquid or this solution or this one or the one above, they would all taste the same. They would all be the same sweetness because the ratio of sugar to water is preserved through each step. There's just different quantities, but the ratio of sugar to water is preserved at each step of this technique. Another example, guys, it's written differently. It's a little bit more scientific. A stock sugar solution has a concentration. This is 150 grams per litre. We're going to come across this notation a lot more in the next couple of weeks. I'm just introducing it now. So 150 grams of sugar in 1,000 mils of water. So that's I know that's my reference ratio. I just better get up the rest of the problem first. So if 12 grams of sugar are to be dissolved to make a solution of the same concentration, how much water do we need? So it's a little bit more wordy than the last example, but the process, guys, is the exact same. grams on the left and mils on the right. This time I'll just write the mils above and the grams above because I think it's neater when we're working out the solution. So now at the bottom, guys, down here, I'm told I have 12 grams. So make sure you put the grams in the right area. And we don't know how much water we need to mix with the 12 grams to make a solution of the same concentration. So now, guys, on the left-hand side, I need to develop my path. And then I'm going to apply it. So straight away, guys, I'm saying, well, what's the highest common factor of 150 and 12? And I think it's 3. Probably 6, but I'm going to go for 3. Yeah, 6 would be the highest common factor, but 3 is easier to get to. So now, how do I get to 3? First thing I'm going to do is divide both sides by 10. That's nearly always my first step. That'll give me 15. Now it's easy to get from 15 to 3, so we'll divide by 10 as my first step. Now, guys, I divide by 5. That'll give me 3. And then I multiply by 4. And there's lots of different ways, guys, of establishing this path. Doesn't matter, you know, there's lots of different ways you can get there. If you know what you're doing, you can sometimes do it in one jump. But like I said, like walking the tightrope, lots of short, quick steps is a lot safer than big leaping bounds. So just check, divide by 10, yep, divide by 5, yep, multiply by 4. So that's the path established. And now I simply just apply it. Divide by 10. I get 100 on the right hand side. Divide by 5, I get 20. And now multiply both sides by 4. 20 by 4, that means I'm going to need, if I have 12 grams of sugar, multiply, sorry, by 4, not 40, I'm thinking ahead. 20 by 4, I'm going to need 80 mils of liquid. So this, guys, is the scaling method. Like I said, there's lots of other ways to go about it. They're all valid, but just I will be using this method throughout this semester and next semester. So it's up to you whether you want to kind of get familiar with it now or not. Ooh. So we'll take a look at another one, guys, now. It's the same problem, only the scenario is different. We're going to look at formulation. So if you take any kind of a tablet that you'd have in your drawer, paracetamol, there's quite a lot of bulking agent, and then there's the active ingredient. So the powder is usually made of 2 bits, a kind of neutral bit, the bulking agent, and then you have your active ingredient, and altogether it's called a formulation. So 500 grams of aspirin formulation contain 20 grams of active ingredient. How much active ingredient is there in 40 grams of aspirin formulation? So be careful here, guys. We have to be a bit careful which is which. We've grams and grams. But if we just think of it, there's 500 grams of formulation. And then we have 20 grams of active. So as long as we keep everything in the right column, we're not going to go too wrong. So we're told we have 40 grams of formulation. And the question is, well, how many grams of active ingredient would there be in that 40 grams of formulation? So you can see, guys, even though the wording is completely different, the problem is still the same. There's our reference ratio. We're given one side of another ratio and we need to find the last bit. So now, guys, I need to get from 500 to 40. So I'm thinking my highest common factor is 20, but I'm going to go for 10 again because it's going to be easy to get to and easy to get out of. 20 will also work, guys, absolutely fine. So first of all, guys, I'll go to 100. Again, lots of short steps. Divide both sides by 5. Then we'll go to 10. Divide both sides by 10. And then multiply by 4. So double check that that works. Divide by 5, yep. Divide by 10 and multiply by 4. So once we've established our path, guys, we just apply it to the other side. Divide both sides by 5. Now divide by 10. It's perfectly fine to bring decimals in there, guys. There's no problem with that. And then multiply both sides by 4. 0.4 by 4. Remember, that's really 4 by 4 is 16. And I have one decimal place in my answer. So 40 grams of formulation would contain 1.6 grams of active ingredient. Now in this case, guys, we write the ratio exactly as it is. We don't try and adjust it to get rid of that decimal, because the question we were specifically asked, how much active ingredient is there in 40 grams? So our answer is 1.6 grams. So don't be tempted. It's perfectly fine to have a decimal in a ratio. Just it depends on the context. If we were asked to express this ratio in its simplest form, that'd be a different deal. I'd have to multiply both sides by 100 and then divide both sides by 4 and then simplify again, and that's the ratio of active ingredient to formulation. But that's not what I was asked. So this is the simplest ratio to express formulation to active ingredient. But the question I was asked, how many grams of active ingredient is there in 40 grams of formulation? So just the context of the question kind of can change as we move around as well. So hopefully, guys, you're familiar with the technique. There's videos on Moodle as well where I go through different problems with the same technique, but it allows you kind of just look at more examples being worked out. So I try and keep the examples from these lectures different than the examples on the videos. So if you're ever confused with something in the lecture, you can kind of delve a bit deeper into the videos, or you can take a look at the notes that accompany the topic as well. So as a student, guys, you're always expected to kind of explore. If you don't know something, take a look around. Where can I find more information? And for this maths module, guys, I hope I have everything you need on the Moodle page. But let me know if you think there's something I should have there, and I'll always include that as well. So I try and kind of make it a complete resource. So now, guys, question 6.3, you know the deal. Pause the video and have a go at these problems here. So they're very similar to the ones we just did, just with different ratio pairs. So I'll let you guys have a go at those. And now we look at the last topic we're going to look at today, split of value into a given ratio. So 360 grams of a compound is to be split in the ratio 345, and how much goes into each part. Now, these are quite simple once you know how to do them, but they can be quite tricky at the start. What you do, guys, is you simply add up how many parts I have. So here we can see there's 12 parts in total. We add the 3 numbers. So now the 360 is to be divided into 12 parts. So each part is actually 30 grams. And now once we know that, guys, it's quite simple, because this guy is going to get 4 parts. 4 by 130. The guy in the middle is going to get 3 parts. And the guy at the end is going to get 5 parts. And when we add these up again, guys, they should obviously add back up to 360 degrees, which they do. 270 plus 90 is 360 grams. Sorry, I'm so used to degrees in trigonometry. So that's the kind of technique there, guys. I think it's fairly simple, straightforward when it's written like that. But usually the ones you'll come across are not as straightforward. And we're given a ratio like this. And sometimes people they kind of go, oh, I'll get 3/4 of this value, and then I'll get half that value, and then I'll get 2/3 that value. You're going to end up with more than 460 grams if you do that. The first thing we need to do, guys, is express our ratio, not in fractions, but in whole numbers. So I need to actually get a common denominator, which I hope you'll agree is 12. Now the left-hand fraction, I multiply top and bottom by 3 to get 12 on the bottom. So I multiply the top by 3 to preserve equivalence. The middle fraction, I need to multiply the bottom by 6, so I multiply the top by 6. The right-hand fraction, I need to multiply the bottom by 4, so I do the same to the top. And now, guys, I can simply ignore the denominators because I've 9 of these bits, is the 6 of these bits, is the 8 of these bits. The ratio is 9, is the 6, is the 8. And when we add these together, 9 plus 6 is 15, plus 8, that's 23 parts to be accommodated. We're told there's 460 grams. So divided by 23. So 1 part is equal to 20 grams. And now I just distribute these. The guy on the left is going to get 9 by 20. He gets 180 grams. He gets 9 parts. The guy in the middle gets 6 parts. That's 120 grams. And the guy on the right gets 8 parts. That's 160 grams. And when we add these up together, the left two gives us 300 grams plus 160. We're back then at 460 grams. So I hope that makes sense. So now, guys, the last question. Oh, sorry, it was a bit quick. I forgot to put in the pause button. Pause the video and have a go at these. And again, guys, these questions can appear in lots of different formats, but it's the same idea. It's crucial at all times, guys, whenever you're given a complex looking ratio, you always need to write it in its whole number equivalent before you do any work. You cannot work with the fractions as they are because they just throw everything sideways. We need to turn it into whole number equivalents before we start doing any maths. So that, guys, sums up the lecture on ratios. Like we really touch it quite lightly, but it is an important kind of part of the foundation of maths that we're building. So thank you for your patience, and we shall chat to you again for lecture 7 when we'll introduce percentages and all of that. So thanks again, guys. We'll chat to you soon.